Everyone, I'm Anjali.K, first year BTech student majoring in computer science and engineering with cybersecurity at SPC Bengaluru. In this video, today I will be explaining principles of programming using C language. So let's begin. Let's first discuss the definition of programming, importance of learning programming, and overview of C language. Programming is the process of creating instructions that enable computers to perform tasks or solve problems. It involves writing, testing, and maintaining code using programming languages. Learning programming principle is crucial as it fosters logical thinking, problem-solving skills, and creativity. It equips individuals with the ability to automate tasks, analyze data, and develop software solutions, which are increasingly valuable in today's technological-driven world. C is a programming language and it is very powerful and widely used language known for its efficiency, versatility, and portability. It serves as the foundation for many other languages and is commonly used in system programming, embedded system, and game development. Now let's explore the basic syntax and structures in C language. Variable and data types are the placeholders for storing data in computer memory. The data types specify the type of data that can be stored in a variable such as integers, floating point numbers, characters, and strings. Control structures are constructs that determine the flow of program execution. They include decision-making structures like if-else statements and switch case statements, and looping structures such as for loops, while loops, and do-while loops. Functions are blocks of code that perform specific tasks. They promote code reusability and modularity. Scope refers to the visibility of variables within a program. Variables can have global scope, accessible throughout the program, or local scope, limited to specific blocks of functions. Let's move to the memory allocations and management in C language. Memory management in C involves allocating and deallocating memory dynamically during program execution. Programmers use functions like malloc, calloc, and realloc to allocate memory from the heap and free to deallocate it when it's no longer needed. Pointers play a crucial role in memory management by allowing programs to access and manipulate memory addresses directly. They enable dynamic memory allocations, data manipulation, and efficient data structures and implementation. Memory leaks occur when memory allocated dynamically isn't deallocated properly, leading to memory consumption growth over time. It's essential for programmers to manage memory efficiently to prevent memory leaks and optimize program performance. Now moving to the modularity and reusability in C programming. Modularity refers to the practice of breaking down a program into smaller manageable modules or functions. Each module performs a specific task, making the code easier to understand, maintain, and debug. Modularity fosters code organization and enhances readability. Reusability is the ability to reuse code modules across different parts of a program or in other programs altogether. By designing functions with well-defined interfaces and clear functionalities, programmers can leverage existing code to save time and effort. Reusable code promotes efficiency and reduces redundancy in software development. Functions and procedures are the breaking down code into small, reusable functions and procedures for improved maintainability and reusability. Libraries and header files are utilizing libraries and header files to encapsulate reusable code components for efficient development, and code organization and implementing structured code organization and best practices to enhance modularity and facilitate code reuse. Now moving to error handling and debugging in C. These are common addressing errors and debugging techniques in C programming. Types of programming: understanding common programming errors such as syntax error, logical errors, and runtime errors are the few types of programming errors can be seen in while running the C program. Debugging tools and techniques, utilizing tools like breakpoints, watch points, and debuggers to identify and resolve problems, and implementing exception handling mechanism to manage unexpected errors and ensure program stability. These are the few error handling and debugging techniques in C programming. Now moving to principles of programming C and understanding the fundamental concepts such as importance of data structures, algorithm efficiency, and complexity analysis. Data structures are fundamental components of computer science that organize and store data efficiently. They provide ways to represent and manipulate data, facilitating the tasks such as searching, sorting, and retrieving information. Common data structures include arrays, linked lists, stacks, queues, trees, and graphs. Coming to algorithm efficiency refers to the ability of an algorithm to solve a problem within reasonable time and resource constraints. Efficient algorithms optimize the time complexity and space complexity, such as execution time and memory usage, ensuring optimal performance for different input sizes. Complexity analyzing involves evaluating the time and space complexity of algorithms to understand their efficiency and scalability. Big O notation is commonly used to express the upper bound of an algorithm, time or space complexity, providing insights into performance characteristics. Now, understanding and implementing arrays, linked lists, and trees are the importance of data structures. Exploring sorting and searching algorithms for optimal proficiency are the algorithm efficiency. And analyzing the computational complexity of algorithms is the complexity analysis. Now coming to the file handling and input-output operations in C. File handling in C involves functions for performing specific operations on files such as opening, reading, writing, and closing files. Common file handling functions include open, close, fread, fwrite, fseek, and feoff. These functions involve programs to interact with files stored on the disk. Input-output streams in C are used to handle data transfers between programs and files or other input-output devices. Standard input-output streams such as stdin, stdout, and stdr are used for reading input from the keyboard, printing output to the screen, and displaying error messages respectively. Now moving to error handling in file operations. These are essential to detect and handle errors that may occur during the file handling operations, such as file not found, permission denied, or riskful errors. Functions like perror and str error are used to retrieve error messages associated with file operations, allowing programmers to handle errors gracefully and provide informative error messages to the users. Now, understanding and utilizing functions for file management is the file handling functions. Working with input and output streams for data manipulation are the input-output streams, and implementing strategies to manage errors in the file operations are error handling in file operations. Now, let's discuss the applications of C programming principles in application development. Exploring the practical applications of C programming language. We can utilize C for creating graphical user interference such as GUI development in applications. We can also implement system level programming using C for efficient system operations. Also leveraging C programming for developing embedded systems and Internet of Things applications. These were the few applications of C language. Now moving to the best practices and coding standards in C, adhering to efficient programming practices, performance optimization techniques such as applying optimization methods for efficient resource usage and improved code execution, code review and version control, utilizing code reviews and version control system to ensure code quality and collaboration is the best practice in coding in C. Code documents and comments, implementing clear and concise documentation to enhance code readability and maintainability is also one of the best practices in coding. Now, coming to the conclusion, future prospects and applications of C programming are the exploring the potential future opportunities and diverse application linked with proficiency in C programming, emphasizing the value of ongoing learning and consistent practice in mastering C programming languages, revisiting and reinforcing the core principles and concepts of C programming. These were the key takeaways and significance of mastering programming language in C. Thank you so much. Do like, share, and subscribe.